Hi everyone, and welcome to the online session about function notations. We are used to seeing functions in the form of y equals, but now we're going to look at it in the form of f of x. So by definition, a function notation is an equation that's written in the form f of x equals, where f of x is the dependent variable. So if we consider this function right here, f of x equals 3x plus 7, they're asking us to find what is f of 2. And if you look at right here, 2 is in place of where the x was right here. So we're going to do the same thing to the other side of the equation. So we're going to plug in 2 wherever we see x. So we're going to be left with 3 times 2 plus 7. Now this is the same thing as 6 plus 7, which then we know is 13. So f of 2 is equal to 13. Right here they want us to find f of 0. We're going to do the same thing with the 0 as we did with the 2, and we're going to plug it in for every x we see in this equation right here. So we're going to have 3 times 0 plus 7. This is the same thing as 0 plus 7, because 3 times 0 is 0, and we still have 7. And 0 plus 7 is 7. So f of 0 is equal to 7. Now if we go to the next page, we see that we have a new function. We have f of x is equal to 2x minus 5. Now we're going to throw in with a negative number. It wants us to find out what f of negative 3 is. So we're going to do the same thing, plug in negative 3 wherever we see x, because instead of f of x, we have f of negative 3. So we're going to get 2 times negative 3 minus 5. This is negative 6 minus 5. We have two negative numbers, so we're going to use same sign sum and get this to be negative 11. So now we're going to throw a little twist into it. We are given what f of x equals, and we need to find out what the x value is that gives us the f of x of 7. So let's plug this in to our equation up here. F of x is 7, so we write 7 is equal to 2x minus 5. We have a subtraction going on right here, so we're going to add 5 to both sides and get 12 is equal to 2x. Because if you add 5 here, we get 0. Now we want to get x by itself, so this is multiplication right here. So we're going to divide by 2 on both sides and get 6 equals x. So the x value that gives us the f of x equal to 7 is going to be 6. Now if you look at here, it looks a little different. It says g of x. This is okay. We can have any letter that we want in front of the x. We could have g of x, f of x, h of x, whatever letter we want, because this is still in function notation. So now it wants us to say, what is g of 4 in the equation g of x equals negative x plus 7? So we're going to do the same thing we did when we had f of x, and we're going to plug this 4 in for every x we see. So we're going to get negative 4 plus 7. And this is equal to 3. So we have g of 4 is equal to 3. Now over here, it's kind of like that challenge problem that we just saw. It says we need to find x when we are given g of x equal to 9. So we're going to plug 9 in for g of x and find out what x value makes this true. So here we have addition going on, so we're going to subtract 7 over, and we're going to get 2 equals negative x. We want x to be by itself and get rid of that negative sign in front of it. So to do that, we're going to divide by negative 1 on both sides. So negative 2 is the x value that gives us g of x equals 9. So, these are some problems that I want you to try on your own tonight. If you can do them, great. I want to see what you were able to do on your own tonight. And so I just want you to look at this function. F of x equals 5 over 6, or 5/6 x minus 3. I know the fraction might look a little scary, but literally you just got to plug the 6 into wherever you see the x. 0 into the x, negative 12 into the x, and negative 18 into the x. So, thanks for listening to this. I want to see your notes tomorrow in class, and make sure you come with any questions that you want me to answer, and you guys have a good night.